morning. Welcome to all. Okay, so in the last lecture, we've seen that okay, before Deepavali, we seen that what is the group action on a set. Okay, what is a group action on a set? Let G be any group and let X be the any non-empty set. An action of G on X is the mapping. Okay, what is the group action? Is nothing but one map from X cross G to X, satisfying these two properties. Xe is equal to X. Okay, or f of Xe is equal to X for all X belongs to capital X and E belongs to capital G. Okay, this X need not be a group. Okay, this is a non-empty set, any non-empty set. Okay, जर तो group असेल तर उत्तमच झालं. And second condition, f of x g1 g2 is equal to f of x g1 into and g2 for all x belongs to capital X and g1 g2 belongs to capital G. So under this condition we say that the x is the G set. Okay, what is the note? G is G set x, that is x need not be a group. Okay, so what is the necessary condition for this x? This x with the non-empty set. Okay, look at here, x cross G, f is the function of x cross G to x comma E is equal to x dot E is equal to x, and x comma G1 G2 is equal to f of x G1 G2. Okay, and we see that the example how the x is equal to 1, 2, 3, 4 up to so on n. This finite set x is the G set on Sn. Okay, what is Sn? What is Sn? Permutation group. Okay, or symmetric group. What is symmetric group? Set of collection of all 1 onto function from set x to x. Okay, containing n elements. This f is the function from x cross G to x, satisfying these two properties. Look at here, f of x sigma naught of x. Okay, so define केला है f of x sigma is equal to sigma of x. What is sigma? Sigma is the element of G, that is Sn, and x small x is the element of capital X. Okay, and the second example is G be a group and H is the subgroup of G. Then what is a set of all right cosets of H in G? Okay, now look at here. This H, that is the any element of the H is of the form G by H, that is Hx. Okay, what is H? Collection of all the right cosets of H in G. So any element from this R is of the form H into X small x, where this small x belongs to capital X. Okay, this small x belongs to capital G, that is group. And here the f is the function from H cross G to H, that is G by H. Okay, any doubt up to here?
No, sir.
If G itself was a set, then X, replace X by G, then G is the G set also. So f is the function from G cross G to G. Okay, now how explaining this X belongs to capital G and this G also belongs to capital G, satisfying these two properties. Hence, G itself a G set. Okay, suppose G is any group, then this set itself a G set. Okay, action of G on G. Okay, so notes are there. And we define some sets. What is Gx? Look at here. What is Gx? Gx is nothing but subset of G. Okay, collection of those elements belongs to capital G such that f of x comma G is equal to x or xg is equal to x. Okay. हाँ नीट लक्ष द्या खूप महत्वाचे डेफिनेशन्स. वेट अ मिनिट. Look at the examples. Also we proved that this relation is the equivalence relation. Okay. Okay, which one? X is equal to yg. Let X be the A G set. Okay, and we define one relation, this one. Okay, symbol of relation, this one, and this relation. If X is related to Y, it means X is equal to yg. Box G belongs to capital G. ओके, जर हा एक्स या वायला रिलेट होत असेल तर त्यांच्यामध्ये काय रिलेशन असेल? व्हॉट इज द रिलेशन? एक्स इज इक्वल टू वाय जी. Okay, where this G belongs to capital G, and we prove that this relation is an equivalence relation. Okay, okay. Example from pilot. Suppose this is the capital set X. Okay, and in which set there are finite elements. Suppose it's x1, x2, x3, x4, x5, up to so on xn. Okay, suppose this relation is an equivalence relation on set X. Okay, what is the relation? मी काय सांगतो तुम्हाला? What is the relation between equivalence relation and partition of that set? Okay, very important concept is there. Suppose this relation is an equivalence relation on set X. What is the equivalence relation? Symmetric, reflexive, and transitive. Is it correct?
Yes, sir.
If these three condition holds, then that relation is an equivalence relation. Now here, this relation suppose equivalence relation. That means it satisfies the reflexive property, symmetric property, and transitive property. And now here, this x1 suppose is related to x2. Okay, that means this x2 is again related to x1. Okay, by symmetric property. Now suppose this x1 is related to x4. Okay, this x1 is related to x4. That means by this relation is an equivalence relation. That means by the symmetric property, this x4 is again related to x1. Okay, and by transitive property, x1 related to x2, x1 related to x4. That means this x2 is again related to x4. Is it correct? Okay.
Sir.
Now, या सेटमध्ये काय तयार झाला? ह्या तिघांचा एक ग्रुप तयार झाला. Okay, suppose this x1 is x1, x2, x3 is not related to the x3, x4, x5, x5, x6. Okay. Now look at it. This suppose this x3 is related to x5, and then by symmetric property, this x5 is again related to x3. Okay. So in the second orbit, okay, in the second part, in the second partition, this x3 and x5 in the second group. Okay, and up to so on. Okay, that means if this is the equivalence relation on set X, okay, त्या equivalence relation मुळे because of this equivalence relation we can partition, okay, partition this set X. Is it correct? असे कोणते तरी पार्टिशन तयार होते त्याच्यात. Okay, is it correct?
Yes, sir.
Sir.
Okay, suppose order of X is equal to n. How many elements are in X? N. Okay, now suppose this is the orbit 1. It is the first part of this set. Now suppose this is orbit 2nd, this is orbit 3rd, this is orbit 4, this is orbit 5, orbit 6, and suppose this is orbit 7. Okay, suppose these are the 7 parts of this set X, and order of X is equal to what? Yeah, small n. Okay, now look at here. We the correct checker. If order of X is equal to order of O1 plus order of O2 plus order of orbit 3 plus up to so on order of orbit 7. Is it correct? Is it correct?
Yes, sir.
Sir.
Okay, that means each orbit is an disjoint. Okay, प्रत्येक ऑर्बिट कसा आहे तुमचा इथे? disjoint. ओके, ह्याच्यामध्ये आणि याच्यामध्ये कोणताही ग्रुप कॉमन, कोणताही एलिमेंट कॉमन नाही याचा. जर कॉमन असला असता, सपोज x5 याच्यातही आहे आणि याच्यातही आहे असं झालं असतं. ओके, x5 O1 मध्ये पण आहे आणि O2 मध्ये पण आहे. सपोज दिस x5 belongs to O1 and also belongs to O2. By this relation, this is the equivalence relation. By symmetric property, this x4 related to x5. Again, x5 कुठे आहे? इथे पण आहे O2 मध्ये. This याच्यामध्ये पण झाला असता हो ना. मग this x4 is again connected to, related to x3. ओके, मग हा ऑर्बिट वेगळा वेगळा होणारच नाही, हा टोटल एकच ऑर्बिट होईल. इज इट करेक्ट?
Yes, sir.
Yes, sir.
Okay, so here each and every orbit is the disjoint orbit. Okay, and the order of that set capital X is nothing but sum of all the orders of the orbits. And yeah, orbitला म्हणतोय आपण xg. ओके, काय काय कोणकोणते डेफिनेशन पाहिलं पहा. ओके, what is gx? This is set g, and suppose this is x, capital X. This x is the g set. Okay, suppose this x is g set. That means that there exists a function between x cross g to g. Okay, sorry, x cross g to x. Okay, satisfying that two property. What is gx? Okay, now this x is fixed. G belongs to capital G. Collection of those elements belongs to capital G such that f of x comma g is equal to x. That means x into g is equal to x. Okay, जे काही तुमचं फंक्शन असेल, काय ते काही रिलेशन वगैरे असेल, काय असेल, ओके, कसं डिफाईन केलं असेल तसं असेल. दिस इज द सेट gx. That means gx is the subset of g. Okay, what is x? G, collection of those elements of x such that f of x comma g is equal to x. That is x comma g is equal to x dot g is equal to x. Okay, for all g नाही बरं का, एका जरी g ला जर तो ही कंडिशन सॅटिस्फाय करत असेल. ओके, हा g कुठून येतोय? कॅपिटल जी. ओके, सो दिस इज दी xg. Okay, now what is gx? xg, sorry, xg. Okay, कोणकोणत्या डेफिनेशन आहेत नीट लक्षात ठेवा, पुन्हा भरवण्याची शक्यता आहे. What is xg now? x equal to collection of those elements of x such that x is related to y. Okay, or y is related to this small x. Okay, what is the meaning of this one? Look at x g is equal to y belongs to capital X such that okay, हा जर x हा y ला रिलेटेड झाला तर त्यांच्यामध्ये काय हे असेल कनेक्शन? y is equal to xg. Okay, y is related to x. That means y is equal to what? xg. Look at here. Okay, if x is related to y, then what is the relation between x and y? X is equal to y. Okay, so the y इकडे आणि x इकडे असेल तर काय होईल? Y is equal to x. Okay. What is xg? Xg is equal to collection of those elements of x such that y is equal to xg for some small g belongs to capital G. Okay, this is important. Okay, that means any element of this set xg is of the form is equal to what is y? xg, where g belongs to capital G. Okay, तिन्ही मध्ये काय होते का पहा नीट लक्ष द्या. Okay, so what is xg? This is xg, that is orbit. Okay, if x1 is the element of capital X, then x1g is the orbit of X. Suppose x2 is the another element, then x2g is another partition of that set X. Okay, provided that this is the orbit 1, this is the orbit 2. So x1 belongs to orbit 1, x2 belongs to orbit 2. Okay, and this x1g is nothing but orbit 1. This x2g is equal to orbit 2. Second orbit. Okay, suppose this is orbit 1, this is orbit 2. This set xg is equal to orbit of small x in capital X under capital G. Okay, so hence the equivalence class containing x belongs to capital X is orbit of X. Okay, so the equivalence class, याच क्लासला काय म्हणतात आपण इक्विव्हॅलन्स क्लास. ओके, सो एव्हरी इक्विव्हॅलन्स रिलेशन फॉर्म्स द पार्टिशन ऑफ दॅट सेट. प्रत्येक इक्विव्हॅलन्स रिलेशनमुळे काय होतंय, त्या सेटचा पार्टिशन येतो. ओके, इफ देर एक्झिस्ट अ इक्विव्हॅलन्स रिलेशन ऑन दॅट सेट, then that equivalence relation brings the partition of that set. Okay, so the equivalence class contain x belongs to capital X आणि आता प्रत्येक पार्टला काय म्हणायचं. सो दिस इज द फर्स्ट इक्विव्हॅलन्स क्लास, दिस इज सेकंड इक्विव्हॅलन्स क्लास. ओके, इक्विव्हॅलन्स क्लास. The equivalence class containing x belongs to capital X is orbit of capital small x. Okay, कोणाचं orbit आहे, orbit of this x, and we denote it by xg. Okay, this is nothing but what, orbit of x under G, orbit of small x in capital X under G. Any doubt?
No, sir.
No, sir. No, sir.
Okay. Look at here. Suppose this one is set X. That is. Okay, and this is the equivalence relation on this set capital X. या इक्विव्हॅलन्स रिलेशनमुळे काय होतं, त्या सेटचे पार्टिशन कसे होतात. पार्टिशन, सपोज दिस वन इज फर्स्ट पार्ट. ओके, सपोज द ऑर्डर ऑफ कॅपिटल X इज इक्वल टू n. This one is second part, this one is third part, this one is the fourth part, and all the orbits are disjoint. Okay, suppose this is gx, sorry xg, that is orbit 1, orbit 2, orbit 3, orbit 4. Okay, and now push on, this is suppose orbit r. Okay, the orbit 1 चा कसा असेल नेचर. What is the set orbit? Orbit 1. What is the nature of this set orbit 1? X belongs to capital X. Okay, X belongs to, suppose this is the x1 belongs to this set. Okay, एखादा एलिमेंट x1 मध्ये आहे. So X belongs to capital X such that x1 related to that X. Is it correct? हा
Yes,
X
sir.
कसा असायला हवा, या x1 ला रिलेट असायला हवा. ओके, समजा याच्यामध्ये ए हा एलिमेंट आहे सपोज, तर हा हे कसा असेल, या x1 ला रिलेटेड झालेला असेल. A is related to x1. If suppose B is in the orbit O1, that is orbit 1, then this B is related to x1. Okay, suppose इथे x2 एलिमेंट आहे, this is x2. Okay, so what is orbit 2? Orbit 2 is nothing but collection of those elements of X such that x2 is related to small x. Okay, suppose small p is there in orbit 2. So this p is related to x2. Okay, आता या a आणि या p मध्ये हा रिलेशन नसेल काही. ओके, जर रिलेशन झाला तर हा ऑर्बिट एकमेकात सगळं मिक्स होईल. Why? Look at it. Suppose this is capital X of topology. Okay, and this is orbit 1, and this is orbit 2. याच्यामध्ये काय म्हटलं आपण, एक्स हा एलिमेंट आहे, ए आहे आणि बी आहे. याचा अर्थ काय, दिस एक्स रिलेटेड टू ए, दिस एक्स रिलेटेड टू बी, अँड ए इज रिलेटेड टू बी बाय ट्रान्झिटिव्ह प्रॉपर्टी. ओके, अँड इफ सपोज x and x2 is contained in O2, belongs to O2. Okay, and P also belongs to O2. That means by the definition of O2, this x2 is related to this small piece of x. Okay, and this is what equivalence relation on set x. Okay, if one of the element, समजा हा A जरी हा element या P ला relate झाला, then by transitive property, by symmetric property, by reflexive property, हा ही याला relation, हा ही याला काय होईल, relate होईल. Then O1 is equal to what? O2 is equal to O. असा, correct? Is it correct?
Yes, sir.
Okay, that's why here all the orbits are disjoint orbits. Okay, hence each equivalence relation, neat लक्षात ठेवा, each equivalence relation brings out the partition of that set. Okay, the next theorem is let x be any G set. Suppose that x be any G set, then okay, order of x g, small x g, that is the orbit, order of that orbit, that is order of x g is equal to index of gx in g. Okay, कसं रीड करणार आहे, index of gx in g, or order of gx is equal to what? Order of g upon gx, that is index of gx in g. Okay, if g is the group, h is the normal subgroup of g, then index of h in g कसा लिहितो आपण, असंच लिहितो ना. What is index of h in g? Order of g by h. कसं फाइंड करतो ह्या, order of g upon order of h. Okay, that is the index of h in g. Is it correct? Okay.
Yes, sir.
So here order of each orbit is equal to what? Index of gx in g. Okay, now look at it. Given that, it is given that capital X is G set. That means suppose this is set X, this is G. So there exists a function between X cross G to X satisfying that true property. Okay, and let X belongs to capital X is any element. Is any element and fixed it. त्याला fix केला आहे. Okay, X is any element of capital X and fixed it. What is the orbit of this related to this element, that is xg. जर हा इथे x1 असेल तर हा इथे x1, h2 असेल तर x2. ओके, तर फिक्स केलं आहे एलिमेंट. म्हणजेच या x ला रिलेट झालेले कोणकोणते एलिमेंट आहेत, दॅट इज xg सेट. ओके, दिस इज इक्वल टू व्हॉट, collection of those elements of x such that this x is related to y, or we can say that y is related to x by symmetric property. So y कसा असायला हवा, या x ला रिलेट झालेला. Any doubt up to here? Okay, any doubt up to here?
No, sir.
No, sir. No,
So
sir.
that is this x is equal to, what is the relation between x and y? X is equal to yg.
IG.
आपण असा डिफाइन केलं ना रिलेशन, फॉर सम g belongs to capital G. Okay, now let R. What is R? Write cosets of Gx in G. Write cosets of Gx. Okay, we know that. What is Gx? It is the stabilizer group. Okay, in capital G. Then what is the order of R? Number of right cosets. Right cosets of Gx in G. Okay, that is order of R is nothing but order of G by Gx. Okay, any doubt up to here? Give it
No,
as a
sir.
question.
No, sir.
Okay, now we have to show that hmm, order of Xg is equal to order of this one. Okay, half because this. Okay, that is number of right cosets of Gx in G. Now define one map. Define a map. Okay, function define. Okay, आधी mapping केलाय त्याला function दाखवायचं. Okay, far from Xg to R. Okay, R हा तुमचा काय आहे set आहे. Right cosets of Gx in G. Okay, what is Gx? Orbit of X in capital X under G. Okay, पहा नीट लक्ष द्या. This is X. This one is orbit under X in capital X under this G. Okay, what is R? Right coset. म्हणजे प्रत्येक एलिमेंट कसा असेल तुमचा इथे G by Gx. Okay. So this is the function between this Xg to this R. This Xg to this R. Okay. This is the function. Defined by कसा डिफाइन केलंय phi of y is equal to ह्याच्यातला एलिमेंट कसा असेल माझा प्रत्येक एलिमेंट Gx into Cg. Is it correct?
Yes, sir.
इनपुट तुमचा y इनपुट इथून आलं. ओके तुम्ही इथे माझ्या फंक्शनचा इनपुट दिस इज Gx. Okay, sorry. X. Okay, orbit. This is my first orbit now. So any level y is from X to G by Gx. So phi of y defined by Gx into G. Okay, now we have to prove that this function is well defined and 1, 1. Okay, suppose now tell me. Suppose I have function, this is set x. Okay, finite set x. And this one is set y. Okay, suppose this contain 4 elements. Suppose 5 elements are there. A, B, C, D, and E. This is the function f. Okay, now I am telling that this function is 1, 1 and on 2. What is the meaning of 1, 1? One element corresponds to only one element of the set. Okay, म्हणजे हा B या 1 ला तुम्हाला suppose this is 1, 2, 3, 4 and 5. Okay, what is the meaning of 1, 1? If this A is related to 1, then this B not related to 1. Okay, हा B कोणाला असेल relate या 1 ला सोडून कोणालाही relate असेल. Is it correct? One
Yes,
element
sir.
corresponds to
Sir.
one element of our donor. Now suppose this is C. This C is corresponds to other than 1 and 2. That is, suppose this is C is related to 3. This D is related to 4. And this E is related to 5. Whether this function is on to whether this function is on to. हा 1 1 तर झालाय आता. ओके, हा फंक्शन ऑन टू आहे का?
Sir.
Why?
Yes, sir.
Because range is equal to
Codomain.
Now it is a function. This function is on to, suppose this 6 element added to our codomain. Whether the range is equal to codomain. Range is equal to codomain आहे का? नाही ना, सबसेट आहे, प्रॉपर सबसेट. ओके, रेंज मध्ये 1 2 3 4 5 हे 5 एलिमेंट आहे, कोडोमेन मध्ये 6 एलिमेंट आहेत, म्हणजे रेंज इज दी सबसेट ऑफ कोडोमेन. इज इट करेक्ट? हॅलो.
Yes, sir.
म्हणजे हा फंक्शन इनटू होईल जर मी हा 6 ऍड केला तर, बिकॉज रेंज इज इक्वल टू कोडोमेन. सपोज हा 6 नसेल तर काय होईल, माझं फंक्शन ऑन टू पण होईल. ओके, म्हणजेच if suppose any function f from set x to set y is 1 1 and onto, then order of x is equal to order of y. Is it correct?
Yes, sir.
Is it correct? एखादा फंक्शन 1 1 आहे आणि ऑन टू आहे, म्हणजेच काय, set order of set x is equal to order of y. Okay, if here if I showed that if this phi is 1 1 and 2, समजा मी हा phi मी शो केला की 1 1 आणि 2 दोन्ही आहे, तर काय होईल, order of gx is equal to order of r. What is order of r? This order of g by gx. Is it correct?
Yes, sir.
म्हणजे तुम्हाला हे सांगण्याचा उद्देश काय आहे, जर एखादा फंक्शन 1 1 आणि 2 असेल तर कोडोमेनचा आणि डोमेनचा कसा असतो, ऑर्डर सेम असतो. ओके, ऑर्डर ऑफ कोडोमेन अँड डोमेन must be same if function is 1 1 and 1 2. Okay, first prove that this phi is well defined. To prove that phi एखादा bit, to prove that phi is well defined. Okay, well defined and 1 1. एखादा फंक्शन 1 1 आपण वेल डिफाइंड काय आहे, एखादा मॅपिंग वेल डिफाइंड आहे, याचा अर्थ काय, व्हॉट इज द प्रोसिजर to show the function is well defined. Take any two element y1 and y2 belongs to domain, that is gx. If y1 is equal to y2, then if it is implies जर y1 is equal to y2 असेल तर तो काय असेल, phi of y1 is equal to phi of y2. जर ही कंडिशन सॅटिस्फाय झाली तर तो फंक्शन काय म्हणतो आपण, phi is well defined. ओके, इज इट करेक्ट? आणि जर हे ट्रू करून आपण हे इम्प्लाइज केलं तर तो फंक्शन काय म्हणतो आपण, 1. ओके, म्हणजेच ह्याला काय करूया तर इम्प्लाइज आणि इम्प्लाइड करूया. सपोज y1 and y2 implies and implied phi of y1 is equal to phi of y2, then this function phi is well defined. Okay, why we are going to prove this function is well defined? What is the meaning, actual meaning of to prove the well definedness? कोणाला माहिती आहे, हा हे मॅपिंग डिफाइन केलं आहे. ओके, वेल डिफाइंड चालतं काय, इफ y1 is equal to y2, that implies phi of y1 is equal to phi of y2. खूप दिवसांनी झालं ना, सवय घ्यायची नाही, घ्यायची सवय नसली की असं, y1 is equal to y2, that implies phi of y1 is equal to phi of y2. Okay, this is the method to prove the function is well defined. Okay, याचा अर्थ काय, suppose this is domain. Okay, x. Okay, this is y. This function is f. Suppose this is y. This is y2. This is phi of y1. Okay, and this one is phi of y2. तुम्हाला दोन दोन एलिमेंट दिसते. समजा हे दोन एलिमेंट, what is phi of y1? y1 is related to this element, that is phi of y1. Image of y, phi. Image of y2, phi of y2. याचाच अर्थ काय, जर y1 is equal to y2 असेल, हे दोन्ही जर एकच एलिमेंट झाले, y1 is equal to y2, then that implies this phi of y1 is equal to phi of y2. म्हणजे हा दोन्ही एलिमेंट वेगवेगळे नसतील, एकच आहे. याचा अर्थ काय, एकाच एलिमेंटला एकच इमेज येतो इथे. ओके, suppose this is y1, this is y2, this is phi of y1, this is phi of y2. ओके, म्हणजे हा y1 या दोन एलिमेंटला, ओके सपोज दिस इज x, suppose this is x2. Okay, image of y1, this is image of again हा y1 एकाच एलिमेंटला युनिक इमेज आहे तुमच्या कोडोमेन मध्ये x, this is y. Okay, so that implies, this statement implies, for every element of x, each and every element of x will get unique image in codomain y. ओके, कळते का काय सांगतोय मी? जर y1 इज इक्वल टू y2 असेल, हे दोन एलिमेंट जर वेगळे नसून एकच असतील तर त्यांची इमेजही वेगवेगळी आहे, एकच आहे. ओके, ओके, पुन्हा सपोज दिस इज y1, this is y2. ओके, this is codomain y, this is phi of y1, suppose this is phi of y2. जर असं होत असेल, y1 हा जर दोन एलिमेंटला जर इमेज देत असेल तर हा y1 आणि y2 हा एकच आहे, आणि हा phi of y1 आणि phi of y2 एकच आहे. म्हणजे याचा सिग्निफिकन्स काय, जसं फिजिकल सिग्निफिकन्स म्हणतो की त्याचा अर्थ काय त्याचा, that means that mapping is, that relation is function. Okay, every relation is not function, but every function is relation. Is it correct?
Yes, sir. Yes, sir.
हा आपण रिलेशन डिफाईन केलाय. हा रिलेशन जर मला फंक्शन व्हायचा असेल तर मला काय प्रूव्ह करावं लागेल, this phi is well defined. Okay, every function is a relation, but every relation is not a function. Why? Because in function we want every element in domain their unique image in codomain. ओके, पण रिलेशन मध्ये तसं चालत नाही. त्याला हा y1 हा इकडच्या दोन एलिमेंटला तुमचा रिलेट करू शकतो, जसं इक्विव्हॅलन्स रिलेशन मध्ये पाहिलं, x1 related to x3, x1 related to x4. ओके, that is equivalence relation आहे, but it is not a function. Okay, so every function is a relation, but every relation is not a function. टॉपिक असेल कोणाचा तरी सेमिनारचा. Okay, so here we have to prove that this mapping is well defined. ओके, तो आधी फंक्शन होतो हे मला प्रूव्ह करावं लागेल, त्यानंतर तो 1 1 आहे हे सांगावं लागेल, त्यानंतर तो 1 2 आहे हे सांगावं लागेल. ओके, so here first step we have to prove that this phi is well defined and 1 1. ओके, एकाच वेळी का प्रूव्ह करतोय पण, कारण की इम्प्लाइड आणि इम्प्लाइड स्टेटमेंट आहे. ओके, सो कन्सिडर एनी टू एलिमेंट बिलॉंग्स टू डोमेन y1, y2. These are the two elements belongs to domain. What is domain? X, such that y1 is equal to y2. Okay, so that implies and implied. What is the nature of y1? If any element belongs to the x, एखादा एलिमेंट x च्या सेट मध्ये असेल तर तो कसा असतो, x is equal to y or y is equal to x. ओके, एक तर असं असेल, हे कंडिशन असेल तर असं असेल, हा असेल तर y is equal to x. ओके, किंवा हा g बिलॉंग्स टू कॅपिटल जी आहे ना, इनवर्स घेतल्यानंतर काय होईल, हा y x g इनवर्स. ओके, या रिलेशन मध्ये हा g इनवर्स बिलॉंग्स टू कॅपिटल जी. ओके, सो नेचर ऑफ दिस y is equal to y1 x is y1 is equal to xg1 and this y2 is equal to x g2. Okay, so this is the nature of y1 and y2 for sum g1 and g2 belongs to capital G. Okay, is it correct? Any doubt up to here?
No, sir.
Okay. हे दोन्ही कशात y1 is equal to y2. That means, that implies xg1 is equal to xg2. Okay, so that implies and implied xg1 g1 inverse is equal to x g2 g1 inverse. Is it correct? By post multiplying by g1 inverse to the both side. Okay, that implies and implied. This is g1 into g1 inverse is equal to e. That is x into e is equal to x. That is x is equal to x g2 g1 inverse. Okay, and this g2 into g1 inverse, g1 and g2 belongs to g. That means the product of these two elements also belongs to g. Okay, that implies नीट लक्ष द्या काय सांग. Is it correct?
Sir.
A belongs to H, then HA is equal to H. The AB, AB inverse belongs to H, that means HAB inverse is equal to H. That means HA is equal to HB. Okay, the post multiplying by B to the both side. इथे काय येईल मग? Look at this G2 into G1 inverse belongs to here what?
G. XG.
GX. ओके, नीट लक्ष द्या. त्यासाठी सांगितलं हा तुमचा कोडोमेनचा एलिमेंट आहे ना. याच्यामधला प्रत्येक एलिमेंट कसा असेल म्हणजे GX into G na. Is it correct? Okay.
Yes, sir.
So here x is equal to x into G2 G1 inverse. Okay, that implies this G2 and G1 inverse belongs to GX. Okay, काय nature काय GX चा सेट चा nature कुठे त्याला वर गेल्याकडे इथे काय होतं x is equal to x G2 G1 inverse. Okay, हा एलिमेंट कुठून होता माझा G मध्ये. Is it correct? म्हणजे हा एलिमेंट गेला कुठे माझा आता GX या सेट मध्ये गेला. Is it correct?
Yes.
Yes, sir.
ओके, म्हणून डेफिनेशन नीट लक्षात ठेवा तुम्हाला. कुठल्या स्टेपवरून कुठली स्टेप आली काहीच कळणार नाही. x इज इक्वल टू x इंटू G1 G2 G1 इनवर्स इज इक्वल टू G2 इंटू G1 इनवर्स इज इक्वल टू belongs to GX. That implies, okay, if A belongs to H, that implies and implied HA is equal to what? H. Okay, so that implies this is GX into G2 G1 inverse is equal to GX. That implies and implied GX is into G2 and this is GX by post multiplying by G1. So we have G1. What is this one? Phi of Y1. What is this one? Phi of Y2. पहा कसा डिफाइन केला पाहिजे. You find the pi. Phi of y is equal to gx into g na. Sorry, okay. So what is this one? This is g1 असेल काय आला आहे y. g2 असेल तर phi of y. Okay. Any doubt? So this function is hence phi is 1 1 वेल डिफाईन. म्हणजे जे आपण केलेला डिफाईन केलेला मॅपिंग हा कसा आहे फंक्शन आहे. डिफाईन केलेलं रिलेशन इज द फंक्शन अँड दॅट फंक्शन इज वन फंक्शन. नाउ टू प्रूव्ह द ऑनटोनेस, prove that 5 is on 2. Okay. What we have to do then? The range is equal to basics गोष्टी लक्षात ठेवा. Codomain. Okay. What is the range? What is the meaning of this one? For every element of codomain, there exists a pre-image in domain. प्रत्येक एलिमेंट म्हणजे कोडोमेनच्या प्रत्येक एलिमेंटसाठी ते काय असायला हवा आहे? प्री इमेज असायला हवा. ओके. म्हणजेच तुमचा हा रेंज इज इक्वल टू कोडोमेन असं असेल. ओके. म्हणजे कोणताही एलिमेंट रिकामा नसेल कोडोमेन. Okay. Let's take any element from the codomain. That is gx into small g. Okay, so this is the element of the codomain. What is codomain? R. Okay, such that g small g कुठून आलाय माझा? Capital G. Okay, so for this small g belongs to capital G. Okay, या g साठी belongs to capital G. We find y belongs to capital X. ओके. माझ्या डोमेनमध्ये मी एक एलिमेंट शोधतोय. कसा शोधतोय? y is equal to x into g. Okay. Then we get there is an element y belongs to xg, that is domain. Okay. म्हणजे हा gx is the any element of codomain such that हा g कुठून येईल माझा? कॅपिटल जी. ओके. तर या कॅपिटल साठी मी काय केलं? वी फाइंड ए एलिमेंट y बिलॉंग्स टू x. ओके. y बिलॉंग्स टू कॅपिटल x such that y is equal to x. ओके. हा x काय तुमचा g सेट आहे ना x. x is the g set. That means कुठले दोन प्रॉपर्टीज सॅटिस्फाय होत आहेत? x, g1 g2 is equal to x, g1 into g2. ओके. हा g कुठून येतोय माझा? इथून. हा x इथून. म्हणजे या आलेल्या एलिमेंट g साठी मी काय डिफाइन केलं? एक एलिमेंट माझा डोमेन मधला x. ओके. एनी डाउट?
No, sir.
Then y is equal to xg. That means हा रिलेशन काय झाला x आणि y मध्ये? For some g belongs to g, then x कुठे गेला? x is related to y. That means this y belongs to the orbit of x in capital X under g. That means हा y माझा डोमेन मध्ये गेला. ओके. स्पीड जायला हवा. अजून आपल्याला डिफरन्शियल इक्वेशन पण संपवायचं आहे. ओके. Okay, so this y is the element from the domain. So for each gx into g belongs to R, that is the each element belongs to codomain. Where x is y is the element from xg, that is domain, such that phi of y is equal to what? G into x into g. Hence phi is on 2. Hence, from 1 and 2. Okay, phi is what?
1 and 2.
And on 2. That means order of domain is equal to order of codomain. What is domain? xg. What is codomain? R. What is R? Order of R is nothing but index of gx in g. Is equal to order of gx. Is the proof. Any doubt?
No, sir.
No, sir.
Okay, that is order of xg is equal to order of order of g upon order of gx. Okay, किती x ची आहे त्याची the second one. Next thing. G be a finite group. Okay, number of elements in G are finite. Okay, and X is finite G set. Okay, then we have to do the first condition, capital order of G. Okay, order of capital G is equal to order of xg into order of gx. Second, order of x is nothing but summation of x belongs to C such that index of gx in G, where what is C? The C is subset of x, subset of capital X containing exactly one element of each orbit of x in G. Okay, the first statement prove that, and the second summation. Okay, let G be a finite group, X be the finite G set, then we have to do that first one. Okay, order of G is equal to order of X G into order of Gx. Okay. From previous theorem. What we have? Order is equal to index of Gx in G. Is it correct? That implies order of xg is equal to order of index of gx in G कसं काढतोय आपण order of G upon order of gx. Okay, so that implies order of G, take towards the left side. So this is order of xg into order of gx. Is the proof first thing. Okay, any doubt?
No, sir.
Just it
No, sir.
Now second one. What is second? Order of x is equal to summation x belongs to C, index of gx in G. What is C? C is the subset of x containing exactly one element of each orbit of x in G. Okay. I see. So let's see. Suppose this is set x. Okay. This is the first orbit containing x. Okay, this is second orbit. Okay, containing x2. x1 is contained in first orbit. This is the second orbit. म्हणजे हा काय partition. Okay, suppose this is x3. Okay, and up to so on. Suppose this is x4, x5. This is x6, and up to so on. These are the xn. Okay, suppose this is x4. This one is x1. Okay, this is first orbit, second orbit, third orbit, fourth orbit, fifth orbit, sixth orbit, and up to so on. N orbits are there. Okay, n partitions are there for this set x. Okay, what is C? Let's see. C is the subset of x containing exactly one element of each orbit of x in G. Okay, suppose this is set x. This orbit contains only one element, that is x1. This orbit contains only one element, that is x2. Okay, so what is C? C is the subset of x containing exactly one element. Okay, हा C काय होता? Subset of x. x1, x2, x3, x4, x5, x6. Okay, हे एवढे सबसेट आहेत, एवढे हे आहेत ऑर्बिट्स ज्याच्यामध्ये फक्त एकच एलिमेंट आहे. x1, x2, x3, x4, x5, x6. ओके, x1 सोडून ह्याच्यामध्ये कोणताही एलिमेंट नाही या ऑर्बिट, म्हणजे हा एकटाच आहे. त्यांच्या स्वतःच्या ग्रुपमध्ये हा एकटाच, या ग्रुपमध्ये हा एकटाच. Okay, so what is C? C is the सबसेट ऑफ एक्स. होईल का हा सबसेट ऑफ एक्स? आता हा आहे का सबसेट ऑफ एक्स? पूर्ण माझा हा सी. Yes, it is the subset of x. Okay, so C is the subset of x containing exactly one element. समजा हा माझा x7 आहे, त्याच्यामध्ये दोन एलिमेंट आहे, x7 आणि x7. मग हा माझा सबसेट ऑफ सी मध्ये येईल का? हा असा x1 x7 आणि
नाही.
x7 नाही, बिकॉज here two elements are. ओके, हा फक्त समजण्यासाठी दिलं तुम्हाला. ओके, then what is the order of x? ऑर्डर ऑफ एक्स मध्ये काय होईल? इज इक्वल टू इंडेक्स ऑफ जी. ओके, इथे 6 होते ना, मग इथे काय होईल? जी एक्स प्लस इंडेक्स ऑफ जी एक्स टू इन जी प्लस अप टू इंडेक्स ऑफ जी एक्स 6 इन जी. ओके, म्हणजे हा सम कुठे रन करायचा आहे? माझा x1 वर, C1 रन करायचा. सी मध्ये किती एलिमेंट्स आहेत? 6 एलिमेंट्स आहेत. कोणकोणते? x1 x2 x3 x4 x5 x6. ओके, सो व्हॉट इज द ऑर्डर ऑफ सेकंड स्टेटमेंट? काय सांगताय? व्हॉट टेल्स द सेकंड स्टेटमेंट? ऑर्डर ऑफ x इज नथिंग बट summation of x belongs to C such that index of gx. ह्यालाच आपण कसं लिहू शकतो? इंडेक्स ऑफ gx म्हणजे order of g upon order of gx. Is it correct?
येस सर.
ओके, याचाच अर्थ काय? हा x सी मधनं घ्या. सी मध्ये कोणता एलिमेंट आहे? फर्स्ट x1. सो दिस इज ऑर्डर ऑफ g अपॉन ऑर्डर ऑफ g x1 प्लस दुसरा एलिमेंट कोण आहे? सी मध्ये. हा x रन करायचा. कशावर? सी वर. सी मध्ये किती एलिमेंट आहेत? 6. ओके, सो दिस इज ऑर्डर ऑफ g upon order of gx. So on order of g upon order of x, gx6, and the sum of all these order is equal to order of x. Okay, any doubt up to here?
नो सर.
Okay, look at don't त्याच्यामध्ये group आहेत. Second group, let C denotes the subset of x. Subset of x, the capital X, containing exactly one element. Okay, from each orbit. Each orbit from capital X under capital G. Okay, what is capital X? Capital X is better. Gx and Gx. Gx definition पुन्हा नीट लक्ष द्या. What is Gx? Sorry, हे मला सांगायचं काय उद्देश? नीट लक्ष द्या. Sorry. What is C? Suppose this is x. This is orbit 1, x1. x1 orbit है, x2 orbit. This is x3. This is x4. Okay, this is x5, and this is x6. Okay, what is C? Need was it? C is subset of x containing exactly one element from each orbit. म्हणजे प्रत्येक ऑर्बिट. These are the 6 orbits of x. Okay, 6 partition of capital X. Okay, 6 parts of capital X. या ऑर्बिट मधनं हा फक्त x1 मी घेतलाय. प्रत्येक ऑर्बिट मधनं each element from each orbit you have to take one element. Okay, From this orbit, this is orbit 1, this is orbit 2, this is orbit 3, 4, 5, this is orbit 6. Okay, so from each orbit we have to take only one element. Okay, what is C? C is the subset of X containing exactly one element from each orbit. प्रत्येक orbit मधला हा एकच element घ्यायचा. Now this C. Is it correct? C is equal to x1, x2, x3, x4, x5, x6. Okay, ह्याच्या ओव्हरमध्ये एकच एलिमेंट नाही, एकापेक्षा जास्तही असू शकतात. ओके, या x1 ला रिलेट करणारे एलिमेंटही असू शकतात. ओके,
Yes, sir.
ओके, नीट लक्ष द्या. हा एक ऑर्बिट आहे. या ऑर्बिटमधनं मी अनेक एलिमेंट, भरपूर एलिमेंट्स आहेत त्याच्यात, पण यातनं मी x1 हा कलेक्ट केला, तो इथे ठेवला. ह्याच्यातून x2 घेऊन मी इथे ठेवला, ह्याच्यातनं x3 घेतलं, इथे ठेवलं. ओके, म्हणजे प्रत्येक ऑर्बिटमधून मी एकच एलिमेंट घेतला आणि तो त्याच्यापासून मी सी फॉर्म केला. ओके, दॅट इज सी containing exactly. C मध्ये कोणकोणते एलिमेंट आहेत? वन एलिमेंट फ्रॉम each orbit. Okay, so what is capital X here? Order of capital X is nothing but summation of, okay, summation X belongs to C. Okay, orbit म्हणजे कसं आहे? ऑर्बिट 1 माझा ऑर्बिटला दुसरं नाव XG. Okay, this is the orbit. Okay, that is equal to काय येणार माझा? Order of X is equal to order of x1g. Okay, if suppose C contains 6 elements, this is x1g plus order of x2g, second orbit, order of third orbit, okay, plus order of fourth orbit, plus order of fifth orbit, and plus order of sixth orbit. Is it correct?
Yes, sir.
So that is x is equal to this statement here. Okay, समजण्यासाठी summation of x belongs to C. This is xg. But by previous theorem, what we have is order of xg is equal to it is order of xg, order of g upon order of gx. Right? Order of g upon order of gx. It's therefore order of x is equal to summation x belongs to C. Okay, x belongs to C. This is order of g upon order of gx. Okay, and each and every orbit here, each and every orbit here, what is joint. Okay, any doubt?
No, sir.
Now the next theorem is very important theorem, one-side theorem. Okay. कसा disjoint कसा prove करायचं? Okay, how to prove the each and every orbit is disjoint? So to prove that, this is the first orbit, suppose. Okay, intersection, this is second orbit is equal to 5. For example, x1 is x1, orbit 1 and orbit 2, we have to prove that is the disjoint orbit. Okay, suppose if possible. Okay, this is the not the part of the proof. Okay, this one is a suppose if possible x belongs to x1g. Okay, and this x is again belongs to x2. Okay, that means these two are not disjoint. Okay, there exists an element x belongs to x1g and x also belongs to x2g. Second orbit मध्ये पण आहे. त्याचा अर्थ काय? By the definition of x1g, this x is related to x2, and this x is again related to x2. Okay, by the transitivity property, partition आहे म्हणजे the equivalence relation असेल. X is related to x1, x is related to x2. This means x1 is related to x2. Is it correct? That implies
Yes,
this
sir.
x1 belongs to x2 ला रिलेट झाला म्हणजे कशाला जायला, त्याच्यामध्ये जायला हवा, सेकंड ऑर्बिट मध्ये जायला. ओके, जर x1 माझा x2 मध्ये गेला, this does not make the partition of that set. Log E set is the contradiction. Why we get this contradiction? Because we assume is wrong. X1 belongs to X1G, X belongs to X2G. Okay, right. Suppose here don't element है. This is first order X1G. This is second order X2G. And this is X belongs to याच्यामध्ये पुन्हा हे आणि याच्यामध्ये पुन्हा so X. This is the not disjoint suppose. तर हा याच्यामध्ये असेल तर हा इथे X1 कुठेतरी असेल हा याला रिलेटेड X2 असेल हा याला हे रिलेटेड म्हणजे हा X काय होईल याला आपण म्हणतो X related to X1, X related to X2, then this X related to X1 and X2. And हा partition करेल का मग हमारे सेटला नाही का okay hence each orbit in capital X is disjoint. Okay, any doubt?
No, sir.
No, sir.
Okay. Wait a minute. Now the next theorem is Burnside theorem. Burnside theorem. Okay, look at the statement. Let G be a finite group. G finite group. Okay, finite group का लिहिलंय कारण की infinite साठी कुठेतरी contradiction मिळत असेल त्यामुळे तो infinite साठी नाही आहे. Okay, statement. Let G be a finite group and let capital X be finite G set. Okay, finite G set. जिथे जिथे finite G set किंवा G set मिळतो तेव्हा ते दोन condition true होईल. Okay. If small is the number of orbits of capital X in capital G, then this R into order of G is equal to summation small g belongs to capital G into capital XG. आता capital XG काय होगा? It's a define केलं त्यांनी. Okay. कोणतं set define केलं बघूया. Okay. Capital XG अजून एक 4 definition झाले तुमच्याकडे. This is GX, हा एक XG. Okay. कोणता XG हा डिफाइन केला की हा पुढे जाऊन हाफ नाही कॅपिटल एक्स इंटू कॅपिटल जी. ओके, चार डेफिनेशन नीट लक्षात राहायला आहे. ओके, सेटचा नेचर प्रत्येक सेटचा नेचर कोण कोणाचा सबसेट आहे वगैरे सगळं नीट लक्षात असायला. ओके, आर इज व्हॉट नंबर ऑफ ऑर्बिट ऑफ एक्स इन जी. ओके, सपोज दिस इज कॅपिटल एक्स. Okay, what is xg? Xg is the subset of x na, so this is capital xg. Okay, orbit कोणाचे असतात? Orbit कोणाचेच असतात xg. Okay, suppose this is the first orbit, second orbit, third orbit. Okay, suppose हे असे पाच ऑर्बिट्स आहेत या x मध्ये दोन काढूया. Again, has set आहे. This first orbit, this second orbit, this third orbit, and this is fourth and fifth. Okay. How many r? Value of r is equal to what? 5. So this 5 into order of g. Okay, g हा तुमचा finite set is equal to काय म्हणतोय काय हे summation small g belongs to capital G to order of G. ओके, हा तुमचा G इथे फिक्स होतो. ओके, दिस इज X सेट. X कुठे येईल, इथे कुठेतरी X चा मला सबस्टिट्यूट. ओके, या प्रत्येकाची ऑर्डर घेतली, इथे अजून एक दुसरा करतोय, तिसरा करतोय, मग प्रत्येकाची ऑर्डर घेऊन त्याची सम केली तर काय होईल, 5 इंटू ऑर्डर ऑफ G. ओके, ओके, one side R into order of G is equal to summation G belongs to capital G into order of xg. Okay, this is capital X. This is X is any element and this is G is fixed. Okay, I say xg and G is fixed element of capital G. Okay, for that G we can find this one xg. Okay, proof. What is xg? For we have right this small g, we have for fixed small g belongs to capital G. This set xg. Palm our definition that x belongs to capital X such that x into g is equal to x. Is it correct? Collection of those elements belongs to capital X such that x into g is equal to x. Okay.
Yes, sir.
What is order of this set xg? This gives, okay, this gives the number of pairs. Number of pairs. Okay, यहाँ पर ऐसा ही लिख सकते हैं x into g is equal to x. क्या f of xg is equal to x असा ही लिखू शकतो. ओके, याची जर ह्याच्यामध्ये समजा 5 एलिमेंट्स असतील, 6 एलिमेंट आहेत, म्हणजे माझ्याकडे काय एलिमेंट असतील, 6 x1 x2 x3 x4 x5. जर 6 एलिमेंट असतील तर काय मिळेल मला, f of x1g is equal to x1, f of x2g is equal to x, x3g is equal to x, x4g is equal to x4, x5g is equal to 5. म्हणजे मला 5 पेयर्स मिळतील. ओके, दॅट मीन्स द ऑर्डर ऑफ xg gives me, okay, order of xg gives the number of pairs x comma g belongs to cross product of x comma, okay, this is capital X and this one is cross product capital G, where g is second member of capital G. Small g is the second member. Okay, member of second member of G, capital G, such that x into g is equal to x. Which is correct? याची
Yes,
ऑर्डर
sir.
म्हणजे काय, म्हणजे it gives the number of pairs. 5 एलिमेंट्स असतील तर 5 पेअर्स येतील मला. x1g is equal to x1, x2g is equal to x2 हे कंडिशन सॅटिस्फाय करणारे 5 लोक येतील. ओके, and let what is n? N is equal to number of ordered pair. Okay, xg belongs to कोणातले क्रॉस प्रोडक्ट ऑफ capital X capital G plus capital G such that x comma g, x dot g is equal to x. ओके, या एका x साठी, एका g साठी हा एक सेट आला x. ओके, दुसऱ्या g साठी इथे काहीतरी दुसरा सेट येईल, तो g फिक्स केला. तिसऱ्यासाठी कोणता तरी तिसरा सेट येईल. ओके, सपोज xg1 असेल, हा काहीतरी xg2 येईल, ही xg3 येईल. ओके, capital xg3. Okay, what is n? N is equal to number of ordered pairs xg belongs to cross product of capital X and G. म्हणजे माझ्याकडे टोटल नंबर किती येतील माझ्याकडे, ते माझ्याकडे टोटल नंबर ऑफ ऑर्डर्ड पेअर्स belongs to x cross g such that this condition holds. Okay, so what is n? That implies capital N is equal to summation G belongs to capital G order of xg. कसाला कळालं आहे. ओके, समजा माझ्याकडे दोनच ग्रुप आहेत, दोनच हे आहेत. दिस इज एक्सपेरिमेंट. एक्स मध्ये टोटल 7 एलिमेंट आहेत, त्याच्यात 5 आहेत, त्याच्यात किती असतील मग 2. ओके, टोटल नंबर ऑफ पेयर्स किती आहेत? n. व्हॉट इज n? n इज इक्वल टू टोटल नंबर ऑफ पेयर्स बिलॉंग टू एक्स स्क्वेअर. ओके, दॅट इज n इज इक्वल टू काय होईल? त्या दोघांच्या ऑर्डरची सम येईल ना. इज इट करेक्ट?
Yes, sir.
That is n is equal to order of xg1 suppose प्लस हा समजून केल्यावर काय होईल? ऑर्डर ऑफ xg. समजा दोनच असतील. ओके, what is xg1? xg1 is nothing but number of ordered pairs. Ordered pairs xg belongs to x cross g, where g is the second member of g such that g1 is equal to x g1 is equal to x. हे कंडिशन होल्ड करणारी नंबर ऑफ ऑर्डर्ड पेयर्स. त्याचप्रमाणे xg2 काय येईल? नंबर ऑफ ऑर्डर्ड पेयर्स such that xg2 is equal to x. मग टोटल नंबर किती झाले माझे? n. n is what? Total number of pairs, all the number of pairs that x comma g is equal to x. Okay, that means x is nothing but what? Summation g belongs to capital G order of xg. Is it correct?
Yes, sir.
Okay. Okay. This is the equation number 1. Now we have gx. What is gx? Nature of this set gx? Collection of those elements of set g such that x equal g is equal to x, where this x is what? Fixed. Okay, high x number fixed height. Okay, so that implies order of gx. Order of gx काय सांगतोय मला? Number of order of gx is nothing but number of ordered pair x comma g. असं लिहू शकतो का? x comma g. Okay, with x is first member, which gives the relation x dot g is equal to x. Okay, याचा ऑर्डर म्हणजे काय? समजा these are the 6 elements, x1 x2 x3, 3 elements असतील. x1 into g is equal to x1, x2 into g is equal to x2, x3 into g is equal to x3. Then order of gx is 3. That is number of ordered pairs with x as the first member. Okay, is it correct?
Yes, sir.
Yes, sir.
So that implies again that n is equal to again the summation x belongs to capital X, fixed x, such that order of this is gx. इथे पण ordered pairs आहे, इथे पण ordered pairs आहे. Okay, so this is equation number 2. Okay, फक्त काय हा तुमचा हा x, this is g, हा इथे तुमचा xg1 xg2 इथे येईल. ओके, इथे काय होईल? xg x1 g x2 असा येईल. ओके, हा जो सबसेट आहे तो x आहे, हा सबसेट आहे तो g आहे. प्रत्येकाचे ऑर्डर काय म्हणजे n आहे. Okay, so we have from 1 and 2. We have from 1 and 2. What is one equation? Summation g belongs to capital G, order of xg is equal to summation x belongs to capital X, order of gx. Is it correct? n म्हणजे
Yes, sir.
काय आहे? Okay. Now, by previous cover. By previous cover. Okay, what we have? Order of G is equal to order of Gx Xg. Okay, so that implies order of Gx is equal to order of G upon order of Xg. Okay, putting the value in equation number third. Okay, writing this equation third. Okay, actually value तो put करायचे आहे. Okay, he will this one. This implies what it implies. Equation 3 becomes order of summation G belongs to capital G, order of Xg. Okay, left hand side as it is. What is the right hand side? Summation x belongs to x. Small x belongs to capital X. Order. Value of this one is order of G on order of Xg. Okay, that implies left hand side as it is. G belongs to capital G, order of H is equal. Okay, here the summation runs over x. Okay, so we can take this order of G outside this into summation 1 upon x belongs to capital X order of G. Okay, the x चा काहीच संबंध नाही त्यामुळे तो आपण बाहेर घेऊ शकतो. Okay, any doubt?
No, sir.
No, sir.
Okay. What we have to do here? लेफ्ट हँड साइड तर मिळालं ना. ओके, ऑर्डर ऑफ जी पण मिळालं ना. इथे काय आलंय म्हणजे समेशन एक्स बिलॉंग्स टू कॅपिटल एक्स अपॉन एक्स जी असं आलंय ना. ओके, जर हा मी आर जर प्रूव्ह केला तर मला स्टेटमेंट प्रूव्ह होईल. ओके, ओके, लेफ्ट हँड साइड आलाय, जी आलाय, फक्त ह्याची व्हॅल्यू जर मी आर मी प्रूव्ह केली तर स्टेटमेंट मला ट्रू होईल. Now, consider R is what? Number of orbits of capital X in G. Okay, in G का लिहितोय आपण? कारण की ऑर्बिट्स तयार केले. ऑर्बिट्स म्हणजे काय होणार? पार्टिशन तयार. ओके, पार्टिशन म्हणजे काय असणार? एक इक्विव्हॅलन्स रिलेशन तिथे एक्झिस्ट झालेलं असतं. ओके, इक्विव्हॅलन्स रिलेशन कसं एक्झिस्ट होतं? x related to y, that means what? X is equal to y, g. Okay, म्हणजे हा g कुठून येतोय माझा? कॅपिटल G. That's why we here written x in g. Okay, r is the number of orbits of x असंही लिहिता आलं असतं. But here we written that r is the number of orbits of x in g. म्हणजे इथं g चा काहीतरी रिलेशन आहे, काहीतरी संबंध आहे म्हणून लिहितात. Okay, number of orbits. Orbits means partition. Partition means equivalence relation. Equivalence relation म्हणजे काय होईल? If x related to y, that means x is equal to y. ओके, हा जी कुठून येतोय माझा? याची. ओके, कळते का काय लिहिलंय असं? प्रत्येक स्टेटमेंट का लिहिलंय, कसं लिहिलं कळालं पाहिजे.
Yes, sir.
Okay. Yes, sir. So R is the number of orbits of x in G. Let suppose O1, O2 up to so on this OR, R orbits are there. Okay. P orbits. R orbits आहेत म्हणजे O1, O2 up to so on OR. These are the R orbits of capital X in capital G. Okay. Suppose this is capital X. माझा काय आहे? O1, O2 up to so on. This is OR. Then what is the order X? What is X? And all the orbits are disjoint orbits. You know that. So this x is equal to what? Union I running from 1 to R OI. Is it correct? Disjoint असू दे नसू दे तरी काय फरक पडत नाही, कारण की आपण युनियन घेतो याचा अर्थ डबल दाखल तरी एकदाच होणार. ओके, एनी डाऊट?
No, sir.
X is equal to union I running from 1 to R OI. कसा लिहूया आपण? This is O1 union O2 union up to so on union OI. Okay, असलेलं आहे. So look at here. That implies summation x belongs to capital X 1 upon order of xg, okay, is equal to summation x belongs to, what is the value of x? This one, union iron from 1 to r over, and this is 1 upon order of xg. Is it correct? The
Yes,
x
sir.
value put up here. Okay, now look at it. The h value find out. Okay, right hand side. Right now, consider the right step. Right hand side, summation x belongs to union I running from 1 to r OI, okay, 1 upon order of xg is equal to, now run this x over this union. Okay, calculate over x summation. X belongs to I is equal to 1, O1, 1 upon xg plus, okay, O1 साठी झाला हा सम, एका ह्याच्यासाठी summation x belongs to O2, 1 upon order of xg plus up to so summation x belongs to OR, 1 upon order of xg. Is it correct?
Sir.
Okay, suppose this is equation number 5. This is equation number 5. Now, we have to find the value of this one first. Okay, ह्याची व्हॅल्यू काढत मग नंतर पुढचं बघूया. ओके, नाउ लेट या O1 मध्ये किती एलिमेंट्स आहेत? ओके, दिस O1 contain suppose n elements are there. Okay, this O1 contain. So let this O1 is equal to T1 suppose, T2 up to so on, Tn, these are the elements are there. Okay, that is the order of O1 is equal to what? N. Okay, now run this x summation on this set O1. So काय येईल summation x belongs to O1, 1 upon this xg is equal to 1 upon x घ्या, O1 मधला एक एलिमेंट घ्या, कोण आहे T1, this is T1g plus 1 upon T2g plus up to so on, किती एलिमेंट्स आहेत? n elements, 1 upon order of Tng. Okay, which is equal to, look at here, हा माझा O1 आहे. ओके, हा सेट मध्ये बाहेर आलो, दिस इज O1. ओके, बाहेर काढ. हाऊ मेनी एलिमेंट्स? T1, T2 up to so on Tn एलिमेंट्स. ओके, आता या ऑर्बिट 1 मध्ये म्हणजेच काय म्हणतात, T1 पण आहे, T2 पण आहे. दॅट मीन्स T1g, ऑर्डर ऑफ T1g is equal to order of T2g. Is it correct?
Yes, sir.
करेक्ट कळायला काय सांगतोय मी? हा समजा ऑर्बिट 1 आहे, दॅट इज इक्वल टू xg. ओके, म्हणजे या T1 ला जे रिलेट कोणते, ह्याचा अर्थ काय, T1g या T1 ला कोण किती एलिमेंट रिलेट झाले, तेवढे एलिमेंट, n एलिमेंट. या T1 ला किती एलिमेंट रिलेट झाले, n एलिमेंट. त्याचप्रमाणे या T2 ला किती एलिमेंट रिलेट झाले, n एलिमेंट्स अप टू सो ऑन ऑर्डर ऑफ Tng. इज इट करेक्ट?
Yes, sir.
Okay, so that is equal to 1 upon order of T1g is nothing but order of O1. Order of T2g is equal to order of O1 again, plus up to so on order of Tng is nothing but order of O1. Is it correct?
Yes, sir.
Yes, sir.
What is order of O1? N. N. Up to so on. How many times? N times ना? N वेळा आलाय ना तो? N.
Yes, sir.
1 upon n, 1 upon n, 1 upon n up to so on. Okay. तुमचा डिनॉमिनेटर सेम आहे हा एक क्लास 1 plus 1 plus 1 plus 1 plus up to so on n times. This is n, which is equal to what? 1. Okay. So here, what is the left hand side? Summation x belongs to O1, 1 upon this is xg. Okay. Summation x belongs to O1, 1 upon xg. Okay. प्रत्येक ह्याची व्हॅल्यू किती आली ते इक्वेशन नंबर 5 मध्ये पहा. ह्याची व्हॅल्यू किती येणार? 1. Similarly, value of this one 1. Value of this one 1. How many times?
R times.
Okay.
R times. Then total 1 plus 1 plus 1 plus up to so on R times. So value of this is equal to अलग answer, which is equal to this one. Value of this one is hence the 2. Okay. Right now, equation 5 becomes summation x belongs to union I is equal to 1 to R O y. Okay, 1 upon xg is equal to 1 plus 1 plus up to so on 1. Okay, times. Which is equal to summation x belongs to equal to 1 to R. Okay, OI 1 upon order of xg is equal to R. So this implies equation 4 becomes okay. This is equation 5. And now the equation 4 becomes summation g belongs to capital G, order of xg is equal to capital G, order of f into R. Okay, so summation g belongs to capital G, this is xg is equal to order of g, hence 2. Okay, any doubt?
No, sir. No, sir.
Okay, पुन्हा एकदा लक्षात. What is Burnside theorem? Let G be the finite group and X be the finite G set. Then R is the total number of orbits of X in G. Then we have to show that R into G order of G. Okay. R into order of G is equal to what? Summation G belongs to capital G, order of Xg. Okay, what is Xg? This one. X belongs to capital X, Xg is equal to X. Okay, that means order of Xg is equal to what? Order of Xg is equal to, it gives me the pair, ordered pairs, such that this condition holds. Which one? X into G is equal to X. Okay. Now let n is equal to total number of pairs, such that X into G is equal to X. Okay, so this n is equal to what? Sum of this order of Xg. That is equation number 1. Okay, what is Gx? It gives the number of pairs. Order of Gx gives the number of pairs such that Xg is equal to X. Okay, that means n is equal to summation order of Gx. या दोन्हीचा अर्थ एकच आहे बरं का या सेटचा अर्थ. Which one? Is Gx and what? Gx and Xg. But this one is the subset of कोणाचा हा capital X. This one is subset of G. थोडाच फरक आहे. Okay. So n is equal to this one. Comparing 1 and 2, you get this one. But the best कदवला तो order of gx is equal to order of g upon order of xg. Okay, but hence the equation 3 becomes now this one. Now here sum is 1 over x. Na? So we can take outside order of g. Okay. So order of summation g belongs to g, order of xg is equal to order of g into order of xg. Sorry, order of x belongs to x. Summation x belongs to x, 1 upon order of x. Okay, now we have to find the value of this one. Okay, this something. Summation x belongs to capital X, 1 upon order of x. Okay, for this one, suppose there are r orbits are there. O1, O2, so on, OR. Okay, look at this one. O1, O2, so on, OR. Then what is x? X is equal to union I, then from 1 to r, OR. Okay, now run this summation. So what is x? Summation x belongs to capital X, 1 upon order of x, g is equal to this one. By putting the value of this x, we get this term. Okay. Now run this sum on O1, O2 up to so on, OR. Okay. Now here calculate the value of this one. Okay. What is the value of this one is? Suppose orbit 1 contain n elements. Okay, x comma 1 चल है O1 and O1 contain n elements now. So run this summation for the n elements T1g, T2g up to so on Tng. Okay, what is the T1g? T1g या सेट आता है जे कोणी T1 ला रिलेट झालेले T2g म्हणजे जे कोणी T2 ला रिलेट झालेले त्याचे ऑर्डर्ड पेअर्स. Okay, look at it. Suppose these are the n elements are there in O1. Okay, this is T1, this is T2 up to so on Tn. T1, T2 ला रिलेट होतोय, T3 ला, T4 ला, T5 ला, up to so on Tn. Okay, that means order of T1g is equal to n. Similarly, order of T2g, that is nothing but number of elements related to the T2. This T2 is related to T1, T3, T4, T5 up to so on Tn and up to so on. That is order of T1g is equal to order of T2g is equal to order of Tng and so on. Okay. So either 1 upon n, 1 upon n, 1 upon n up to n times we get n upon n which is equal to 1. Okay. म्हणजे O1 साठी order किती आली 1. O2 साठी किती येईल सिमिलरली 1. ओके, up to so on किती रूट्स आहेत एकूण असे r रूट्स. That's why 1 plus 1 plus 1 up to so on r times. Hence we get the value of this one is r. Hence from equation 4 we get the result. Okay, any doubt?
No, sir.
Okay. So next point is very important topic, the class equation of group set and net check example. Okay, the group set, what is the class equation for this group? Okay, heading here, remaining part of there. Okay, this is the next point, class equation of a group. Okay, by using Burnside theorem, we define the equation for a group, and that equation is nothing but class equation. Okay, समजा एखादा ग्रुप दिलेला आहे. ओके, त्याचे किती प्रकारे पार्टीशन होत आहे? 1 2 3. ओके, 3 पार्ट्स होते समजा. ओके, ह्याच्यामध्ये समजा एक एलिमेंट आहे, ह्याच्यामध्ये 2 एलिमेंट आहे, ह्याच्यामध्ये 3 एलिमेंट्स आहेत. या फर्स्ट पार्टमध्ये एकच एलिमेंट. This contains 2 elements. This contains 3 elements. Then, what is the equation? Class equation of that group? 1 plus 2 plus 3. That is the order of that group 6. And this is the class equation for this thing. This thing is element. 1 plus 2 plus 3. This is the class equation for yes 3. Q8. Q8 contains how many elements? 8 elements, na? 1 plus 1 plus 2 plus 2 plus 2. This is the class equation for Qn. हे कसं आपण नंतर मग बघूया. Okay, suppose this is Qn containing 8 elements. The first orbit contain how many elements? 1 element. Second orbit contain how many elements? Again 1 element. This third, fourth, एकूण 5 क्लास आहेत आमच्याकडे. ओके, आणि ह्या प्रत्येक ह्याला म्हणायचं क्लास, प्रत्येक ऑर्बिटला म्हणतो क्लास, याचा क्लास, याचा क्लास, याचा क्लास. ओके, दिस क्लास कंटेन 2 elements, 2 elements, 2 elements. ओके, जर एखादा ग्रुप अबेलियन ग्रुप असेल तर काय होईल? G is abelian and order of G is equal to finite, suppose n, then the class equation for that group, okay, class equation for G of G is equal to 1 plus 1 plus 1 plus up to so on 1 n times. So this is the class equation for that. Okay, हे कसं येईल काय येईल हे उद्या आपण एक्झाम्पल घेऊन पाहू. ओके, एक्झाम्पल म्हणजे थेरी ब्रेक परवा दिवशी. ओके, त्यानंतर येतोय सायलो ग्रुप. ओके, व्हॉट इज मीन बाय सायलो ग्रुप, सायलो सब ग्रुप, सायलो TSHG, 2SHG. ओके, कॉची थेरम. ओके, या आठवड्यात कसं करून हा ग्रुप थेरी संपवायचा आणि पुढच्या आठवड्यात आपल्याला डिफरन्शियल इक्वेशन चालू करायचं. ओके, एनी डाऊट ऑफ यू? काय
No,
डाऊट
sir.
असतील तर विचारू शकता. ओके, वेट.